So we just saw in the last video the idea of completing the square and just getting a perfect square trinomial, how to figure out the third term, the constant term, if we know the first two, and then how to factor it into its perfect square form. Now we're going to use that fact or that idea to solve equations. Okay, and we're going to have to come up with the perfect square trinomial and then factor it on the fly in the middle of another problem. Okay, and so just a quick example, this is a very basic one. Something like x squared plus 10x plus 25 equals 4. Well, this is a quadratic equation. We learned how to factor, we learned how to solve these using factoring, back in chapter 5 or something. It's been a while now. And to do that, you would move the 4 over, get a 0 on one side, factor and solve. But now we can actually utilize this perfect square trinomial idea, and I can look at factoring the left side here. Because it's a perfect square, I can turn it into x plus 5 quantity squared equals 4. Okay, and because the entire side here is raised to a second power, I can then apply the square root property, which we saw in previous videos, kind of like taking the square root of both sides but using the plus or minus. So the square root property will turn this into x plus 5 equals plus or minus the square root of 4. Now we know what the square root of 4 is. That is really plus or minus 2. And if I were to subtract this 5 from both sides to isolate the x, I get minus 5 plus or minus 2. Now, of course, that gives me two answers. One of them using the plus and one of them using the minus. So you get negative 5 plus 2, that's a negative 3, and negative 5 minus 2, which is a negative 7. So we're going to have two solutions to this equation. They're going to be the solutions negative 3 and negative 7. Okay. Now, just as a side note, a very quick side note, if I had used the factoring technique that we did in the past, I would have subtracted the 4 from both sides. Using the factoring idea, I subtracted the 4, so I get x squared plus 10x. If I subtract 4 from 25, I would get, what's that, 21? Equals 0. And then I'd be looking for factors of 21 that add up to 10, which of course are 3 and 7, right? Factor it. And then set each factor equal to 0. And you would get x equals negative 3 and x equals negative 7, which, lo and behold, are the same answers we got by completing the square. Okay? So, same answers, but a different technique. In purple, I have the completing the square. In red, I have the factoring idea that we learned in chapter 5. Okay? Same answers, though. Okay, so let's take a look at one where it's not so straightforward. This one's nice because I already had it in this perfect square form, perfect square trinomial. But it may not be the case where we have that. So, for instance, you might start out with something like x squared plus, let's go with 6x minus, I don't know, 10 maybe, is equal to 0. And so here I'm looking at this thing and I don't see a perfect square trinomial. I don't even have a perfect square on the end. And so what I need to do is create a perfect square trinomial. I need to make the left side look like the left side of this formula. And so we learned how to do that in the previous video, but what I need to do is get rid of this constant and give myself an empty space here to work with. So I'm going to start out by adding the 10 to both sides. So I'm going to get x squared plus 6x equals 10. Okay, and now I'm going to complete the square. I'm going to fill in a blank here, kind of like we did before. I'll put a plus in there. I'm going to fill in the blank. And to fill in the blank, we're going to cut the 6 in half. 6 divided by 2 is 3. We're going to square the 3, which of course is 9. Okay. Now here's the problem. We have a property of equality, an addition property, which basically says if I got to add a 9 to the left side, I sure better add the 9 also to the right side. Can't just throw a 9 on one side of the equation without doing it to both sides, just like we did the 10 up here. Okay, now doing that changes the right side a little bit. So I've got x, actually, yeah, let's just write this out. X squared plus 6x plus 9 equals 19. Okay, but now my left side is a perfect square trinomial. I can factor it, just like we did in the previous example. I can factor this into x plus 3 squared, or x plus 3 times x plus 3. And that will equal 19. So now we take the square root property, or take the square root of both sides, however you want to look at it. X plus 3 would equal plus or minus the square root of 19. I then subtract a 3 from both sides. This root 19 won't simplify, and so my final answer is just going to be the minus 3, or the negative 3, plus or minus the root of 19. So my final solution set is going to be these two values, one having the plus in the middle and one having the minus in the middle. Okay. And so these two values, negative 3 plus root 9 and negative 3 plus root 19 and negative 3 minus root 19, those two values will be solutions to this original equation if we were to plug it back in.